so one of the big things that we suggest at Arm & Hammer is a multi-hurdle, multi-technology approach. So if you're using one chemistry throughout your whole process, we encourage try multiple chemistries because they have different modes of action.
Hello, me folks. Welcome back to the MeatsPad podcast. We are on day 3 here at the Reciprocal Meat Conference 76th here in Minnesota. But we have a guest today that we ran into yesterday. Like, we have to talk about antimicrobial interventions because it's been a while since we last spoke about lactic acid, about all those hurdles that we need to have in place. And we'll talk a little bit about HACCP here in a minute. We want to welcome Steve Larsen, Senior Manager and Tech Services at Arm & Hammer. Welcome, Steve.
Thank you very much. I'm happy to be a part of this podcast.
Yeah, absolutely. And I think let's jump on the topic right away. We'll talk about interventions. Can you just briefly describe what an antimicrobial intervention is? And then we can go from there to just get more in depth. Maybe why is that important for the meat industry, and some of the types that we can find out there?
Yeah, absolutely. And I think the simplest definition of an intervention or an antimicrobial is just something that can be used to lower bacterial counts. Water has been shown to be a good intervention. Within carcass cabinets, you could use water as an intervention. Most use some type of chemistry to help achieve a further reduction. Just again, a simple definition would be something to lower the the bacterial concentration of whatever product you're applying it to, carcass, a piece of meat, maybe even equipment.
Yeah, no, absolutely. And I think you mentioned hot water, and sometimes. And I've been into some small facilities and sometimes mid-sized facilities, and it's like, I don't have a cabinet. I don't have the resources to put a tunnel, right? But it's like, you can use hot water as a treatment, and it works as good as any other antimicrobial. And this is good to mention because we think, oh, we need to buy this chemistry or this chemical. But there's some alternative options for especially small folks, right?
Absolutely. There's a lot to think about when you want to put in an intervention. Hot water could be used. Sustainability is a big topic right now. So how much water are you using within your overall system? And one thing that we preach is use data to make your decisions. So if you want to use hot water or lactic acid or PAA or hyperbromous acid, make sure you do your due diligence and get the research that the company brings to you and show that it's effective. And then once you implement it, make sure you monitor it and show that you're getting the reduction or you're achieving the objective that you want to with that intervention.
And we were talking earlier before it started recording about that repeated exposure to a given antimicrobial, or even we talk about surface sanitizers. But I think maybe we can start to define what this is, because there's some folks out there that, I've always been using lactic acid for the last 5 years and the same sanitizer to clean surfaces. So I think maybe we can explain our audience what this is.
Yeah, so one of the big things that we suggest at Arm & Hammer is a multi-hurdle, multi-technology approach. So if you're using one chemistry throughout your whole process, we encourage try multiple chemistries because they have different modes of action. They kill pathogens in a different way. So this way, these pathogens aren't exposed to the same mode of action repeated times and could potentially develop some type of resistance or less efficacy with that mode of action or with that chemistry. So if a packer or processor, and the sanitation's been doing this for many years of mixing up sanitation chemistries to make sure that they don't expose the plant to the same chemistry over and over again. A multi-hurdle, multi-technology approach is something that we need to start talking about in our industry.
Yeah, and you mentioned hyperbromous acid and some alternatives, because we always think about antimicrobial like an organic acid, and we think about the same type of antimicrobials, and there's some alternatives. And I had the opportunity to collaborate in some of the latest research on new alternatives, and this one we talk here in a minute about hyperbromous acid, or the bromine. We did a case study with, and I think we had Dr. Greg and Dr. Phoebus like over a year ago. We spoke about some of the results of this, that we have we're capable of doing also slaughter and apply an intervention at the VRI at K-State. And it's a very unique facility, because you can actually spray pathogenic bacteria and then put an intervention and look at, you mentioned in the beginning, the lowering the bacterial loads on the surface. Explain us a little bit about this new alternative, or this new hyperbromous acid, what this is, what are some of the benefits of using this, and I mean, maybe we can take as a reference other interventions.
Yeah, absolutely. And, I want to give a shout out to Dr. Phoebus and his group for doing that study. And I think it was funded by NAMI. So thank you, NAMI, for funding some valuable studies. But one of the chemistries we have at Arm & Hammer is hyperbromous acid. And it's in the halogen in the element field, similar to chlorine. So it's a halogen, it's an oxidizer, but it's a near neutral pH. And what that means is it's not as acidic as a lactic acid or an organic acid. So there are a lot of trade-offs when you're thinking of what chemistries or antimicrobials you need to use. Cost is always a big one, right? But what we found out, not only cost to buy the chemistry, but it's cost that an acid would do to your infrastructure. If it chews up your concrete, your steel, things like that, where you need to have some operational costs to repair that. So there's more cost than just the chemistry itself. Organic acids is great. How does it affect your product? Are there quality issues that your chemistries are affecting? Is there meat quality issues, things like that? So there's a lot of opportunities to look at different chemistries and see what best fits your objective that you're looking for.
As far as the use of hyperbromous acid, what will be some of the main differences compared to, okay, we have this step that we apply either a prussic acid or lactic acid. So I know there can be a pre or a post-harvest intervention sometimes. And there's also if it works best during chilling or it works best before chilling. So I think you can explain and go more in depth.
Absolutely. So for hyperbromous acid, it's an interesting chemistry because it comes in a nugget form about the size of your pinky fingernail, the thumb fingernail, and it goes into a charging system which looks like a water softener system. You got your house water coming in through there, mixes up, get your concentrate. Concentrate comes out, and then we dilute it to the specified application rate. We are approved in red meat up to 900 parts per million to apply, and in poultry, we are approved up to 450 parts per million. And as far as applications, wherever you could pipe water, we could put DBDMH or hyperbromous acid. So we've seen applications in the beef industry in carcass wash, spray chill, head and meat wash. In the pork industry, we've seen carcass wash applications or spraying primals for shelf life extensions. And in the poultry industry, we've seen some dips and we've seen some sprays, New York rinses, things like that. So it's a very versatile product that can be part of anybody's food safety operation.
And operational wise, how is this to get to that concentration? Because sometimes I've been across some companies, especially more South, Mexico, Central America, that their chemical supply will tell them, okay, just mix this amount of this chemical with water, and that should be good to go. Yep. And sometimes they tell them, well, it's good that you trust your chemical supplier, but you need to have an objective method, so you can every day or every time you have a batch, you're measuring the concentration. Maybe we can talk about this.
No, absolutely. No, yeah, no, you're spot on there because as part of when we implement a hyperbromous acid intervention, we send out equipment to measure the concentration. So the house water comes in, mixes up with the nuggets, concentrate comes out, we dilute it, and then as part of the HACCP plan, some packers measure every hour, measure the concentration every hour with a hanometer. So they take a little vial of the concentrate coming out just to verify that it's at 300 parts per million or whatever the target concentration is. Then they'll jot that down to make sure they're within range. And usually if the target's 300, the range will be 250 to 350. So just to make sure there's because one thing we've noticed is temperature of water can affect concentration levels. So if you have different surges of water temperatures, your concentrations could go up and down. So we recommend measuring it periodically to make sure that you're within that stable range.
And the temperature of the water, what is the recommended temperature?
There's really no recommended temperature. Our recommendation is as long as you have a fairly consistent water temperature, because we can size the system. When I say size, number of tanks to get usage rate, because we'll need to know your water temperature, your water volume if you're going to spray it in a carcass wash cabinet or spray chill system, or how much product do you need to use, and that'll help us size the system to put in your facility. And then pressures, volumes, and whether it's gallons per minute or gallons per carcass, however you want to measure it. So this way we can adequately put in the right system for your facility.
Yeah. And you mentioned at some point sustainability. Yeah. And I think as we continue this path in maybe 2-3 years, I'm imagining that we'll have all these antimicrobials. They'll have to be using less water. So I think a lot of the new research, because there's a limited resource, right? So I don't know what you think of this, but
yeah, no, Arm & Hammer. So our Arm & Hammer's parent company, Church & Dwight, has been one of the forerunners in sustainability, and we have here at Arm & Hammer looking into sustainability, especially a lot, not only our food safety products, but all of our products in Arm & Hammer's stable. But we're looking at can we recirculate hyperbromous acid? If we can, how does that look like, and what does that look like? And also reuse or recycle upstream, right? So if you use it in a carcass wash, can you use it to the residual, capture that and use it upstream to clean pens or hide washes or something like that? So we're looking ahead of that to make sure that we are as sustainable as possible in water usage, because we know that that's a big target for a lot of our customers, and we want to help them satisfy their sustainability goals.
Perfect. What a very good word of advice for small and mid-sized processors that are maybe or expanding their facility and maybe thinking of adding a cabinet for spraying. And I think it's very good information. Before we let you go, please tell us about your background. I know you were telling me a little bit earlier about how this passion of it's what food safety / equality. It's a little bit about everything, and I think that's the value of a meat scientist. Like, you have to understand a little bit of everything. It's when you think about meat, it's just meat, no, but it's wide. And we spoke with Colette about this. And
yeah, no, absolutely. So my background, I grew up in a small town in southwest Iowa. Didn't grow up on a farm, but helped a lot of farmers out, doing whatever they needed to help get done for the day, the week, the month, the year. Thought I wanted to be a veterinarian. So like a lot of kids in Iowa, went to Iowa State thinking I was going to be a veterinarian. I took Animal Science 270 with FC Parrish, and he talked about this thing called meats judging. And they had a curriculum there where you could go every Tuesday night to 475C for meats judging at Iowa State. After that, I was hooked. I decided that I don't know if I really wanted to be a veterinarian, but this meats industry was phenomenal. I got to judge beef carcasses on the rail, look at pork carcasses, lamb carcasses, specifications, right reasons. So FC said, hey, well, why don't you just come out for meats judging? Oh, what's meats judging? Well, you get to travel to these different conferences and whatnots, and part of a team of 10. And so I decided to go out for meats judging, and Best experience of my life. Got introduced to meats judging, AMSA. FC had a position open for a master's candidate looking at conjugated linoleic acid effects on meat quality and belly quality. So I got to study that, looking at different meat aspects or meat quality aspects of what CLA did to various primals in pork carcasses. And then I got to coach the meat judging team, introduced to AMSA back in the late 90s. So I've been an AMSA member for over 20 years now. So it's just been a fantastic experience. After I got my master's in meat science, had the opportunity to work out at the vet school to get a PhD in veterinary microbiology, looking at salmonella in the coal sow industry. Excellent experience with Dr. Scott Hurd, Dr. Jim McKean. Got to work with a lot of pork industry professionals out there and food safety. And I thought that was a great career move because I don't know, as you said, the meat science aspect of it, and then the food safety aspect of it, pre and post harvest. And then I had the opportunity to work for Tyson Foods when I graduated with my PhD, with Craig Bacon, Len Yingst, Bob Love, the whole group there at Tyson Foods. You know, and my boss, Charles White, who's retired now. Excellent opportunity. And then after that, went to the National Pork Board, the checkoff organization. Got to represent pork producers for 13 years, and that was an awesome experience. Pork producers are salt of the earth people that feed the world, you know, so it was an excellent opportunity. And then the last 4 years I've been here at Arm & Hammer. Last year I've been leading their technical services group pre and post harvest for beef, or for poultry, pork, and post harvest beef. So it's been an excellent ride, great experiences, and I'm just looking forward for the next 10 years.
Absolutely. Well, thank you a lot for this information. And again, I think this is very valuable. I don't think and we haven't touched and go more in depth about this new alternatives. Well, thank you a lot for your time.
Hey, thank you very much. And just one last point. No matter how big or small you are, please reach out to us because we want to help you achieve your food safety goals out there in these establishments.
Absolutely.